Hi friends, in this video we are going to see the behavior of AC if it is passed through series connection of resistance and a capacitance. So I am having a diagram where resistance R is connected in series with capacitor C and the whole circuit is connected across a sinusoidal AC voltage denoted as Vm sin omega t. This will give rise to a current I. This current I is flowing through resistance R, give rise to a voltage drop across a resistance VR is equal to I into R. Being a series circuit, same current I is going to flow through this capacitor C, give rise a voltage drop across pure capacitance denoted as Vc equal to I into Xc, where Xc is a capacitive reactance given by 1 upon 2 pi Fc. Now we have seen for a pure resistance, voltage and current are in phase, that means angle between them is 0, and for a pure capacitor, voltage lags current by 90 degree, or you can say current leads voltage by 90 degree. So this will be a phasor diagram for pure capacitance. Now total voltage supplied V is nothing but an addition of these two voltages. So by Kirchhoff's voltage law, I can say V bar equal to VR bar plus Vc bar, because voltages are vectors, along with the magnitude it will have phase angle associated with it. Since it is a series circuit, I consider I as a reference. VR will be in phase with the I and Vc will lag this I by 90 degrees. So I am getting Vc along negative imaginary axis. Phasor addition of these two will give rise to a voltage V. Now this voltage V is a applied voltage, this current I is supplied by the voltage. So ultimately the angle between them is phi, and the angle is such a way that this voltage is behind this current I in anti-clockwise direction. So I can say in series capacitive circuit, the current leads the voltage by angle phi, or in other words, voltage lags current by angle phi. If I consider this part of a phasor diagram, it will be a voltage triangle like this. In voltage triangle, I will get this side as VR given by I into R, this side as Vc given by I into Xc, and diagonal is nothing but V equal to I into Z. Now from the voltage triangle, what I can draw a conclusion? From the voltage triangle, V is nothing but root of VR square plus Vc square. Being a right angle triangle, I am applying Pythagoras theorem to get the magnitude of diagonal. VR we know it is I into R, Vc I into Xc. So if I calculate V, I will get as I into root of R square plus Xc square, which I denoted as I into Z if I consider Z as root of R square plus Xc square, which is nothing but impedance of the circuit. So whatever discussion we have done for series RL circuit, same will be true for series RC circuit also. So let's define a impedance. So impedance is defined as the opposition of a circuit to flow of alternating current. So it is just like a resistance, hence unit is ohm and it is denoted by Z. So for a capacitive circuit, the impedance triangle will be like this. Here it is R, Xc and diagonal is Z, which will make angle phi with R in clockwise direction. Hence I can say from impedance triangle, this R is nothing but Z cos phi and Xc is Z sin phi. Suppose I want to write in a complex form, I will get Z as R minus Jxc. In phasor form, it will be mod Z, nothing but the magnitude of Z given by root of R square plus Xc square at an angle minus phi. Why minus? Because Z will make an angle phi with respect to R in clockwise direction. What we have assumed earlier, anti-clockwise direction is positive angle. Here I am having a clockwise direction, therefore angle is minus. So we have to remember phi is always negative for capacitive circuit. Let's talk about the power. Instantaneous power in RC circuit is given by P equal to instantaneous voltage multiplied by instantaneous current. We have taken a voltage as Vm sin omega t, and hence we are getting current leads voltage by angle phi. So, I equal to Im sin omega t plus phi. So, if I use a trigonometry formula, what I will get? Vm Im multiplied by cos phi minus cos 2 omega t plus phi divided by 2. I am getting two terms. One term is Vm Im by 2 cos phi minus Vm Im by 2 cos 2 omega t plus phi. Now, thing is that since both the terms are looking like a sinusoidal term, but with respect to omega t axis, this term if I use for calculation of average, I will get the answer as 0. Whereas, though it is looking like a sinusoidal term, but it is sinusoid for phi, but we are talking about omega t axis. So, for omega t axis, this term will act as a constant. Hence, average power consumption over a one cycle will be P average equal to Vm Im by 2 into cos phi, because the average of this term will be 0 over a complete cycle of omega t ranging from 0 to 2 pi. So, P average equal to Vm by root 2 multiplied by Im by root 2 into cos phi. Maximum value divided by root 2 is RMS value. Hence, P average you will get as Vrms IRMS into cos phi. Along with the power P, we will have two more powers. We have seen same theory at the time of inductive circuit also. So, apparent power is nothing but a diagonal of this power triangle. Real or true power is nothing but the power along the x axis, and reactive power is nothing but a power along j axis, which is a imaginary axis. Now, S is the apparent power, which is the multiplication of voltage and current, and the unit is volt ampere or kilovolt ampere. Power P is a real power, it is nothing but a product of voltage and active component of current, which is nothing but I cos phi. So, I will get a P as Vi cos phi, unit is watt or kilowatt. Reactive power is Q, nothing but a product of voltage applied and reactive component of a current, which is I sin phi. So, ultimately I will get a Q as Vi sin phi. Since it is a reactive power, unit is volt ampere reactive, or it will be kilovolt ampere reactive. So, here again I am getting a cos phi as a power factor, okay, and power factor over here is nothing but a factor which is responsible for obtaining true power out of the supplied or apparent power. Again, here the nature of cos phi is decided by the position of current with respect to applied voltage. For RC circuit, current leads voltage by angle phi. Hence, cos phi is a power factor which will be in leading in nature, because we have seen cos phi is positive for positive angle as well as negative angle. So, how to determine the nature? The nature is determined by the position of current with respect to voltage. For inductive circuit, current lags voltage, therefore power factor is lagging. For capacitive circuit, current leads applied voltage, therefore nature of power factor is leading. Thank you.